This is 8-4, solving quadratic functions by graphing. The difference here is we've been using standard form of ax squared plus bx plus c is equal to y. Now it's going to be equal to 0, and that means that you have to solve the quadratic equation. So if you are solving the quadratic equation, you're looking for x-intercepts. The x-intercepts are also known as the zeros or the roots. These are all solutions to quadratic equations. So if you see in the first graph, there are no x-intercepts, that's why there's no solutions. In the second graph, there's one x-intercept, that's why there's one solution. And in the last graph, there's two x-intercepts, that's why there's two solutions. So at first, we're given a quadratic equation where it's equal to 0. So I know that we're going to have to solve here, but it's asking us to write the related function. So we just turn the 0 into a y. That is our related function. Okay, so just a reminder that when you have your equation or your function, it's ax squared plus bx plus c. So a in this case is 2. B is missing because there is no x. So that's what makes it 0. And the number by itself, the c, is -2. So when we're about to find the axis of symmetry, which is x equals negative b over 2a, there is no b. So I know it's just going to be 0 over something, which is 0. I can write it as 0 over 2 times 2 for 2a, but it's really just 0. And then to find the vertex, we take that x value, and we're going to plug it into the original equation so that we can get our y value. So we're going to plug in 0 for x into the original equation. And we're going to find out what the y is equal to when we do that. So you should get -2 for that. Okay, the y-intercept is -2 because that's our c value. And now we're going to find two other points. So we can plug in any x values we want to find the 2 points. So when choosing the 2 points, the 2 other points, I usually like to graph it first so I can see what's near the axis of symmetry that we haven't already used. The axis of symmetry is 0, so maybe 1 and 2 would be good, but it might be better to graph first just to make sure. Okay, so when we are graphing, I picked the points near the axis of symmetry. So I picked like x is 1, for instance, and I plugged the 1 in to the original equation, the 2x squared minus 2. So 2 parentheses 1 squared minus 2, and that gave me 0. So that gives us an ordered pair of 1, 0. Remember to reflect that on the other side of the axis of symmetry. So that also gives me -1, 0 when I reflect it. Then I picked another point. I picked 2, and I'm going to plug that into the original equation. So 2x squared minus 2. 2 parentheses 2 squared minus 2. I calculate this, and I get 6. So my ordered pair is 2, 6. But when I reflect that to the other side of the axis of symmetry, I also get -2, 6. And the last step is to find the zeros. The zeros are the solution. So if I connect my dots here and make my parabola, remember the solution or the zeros are the x-intercepts. So the x-intercepts in this case are -1 and 1. So we've just solved our quadratic equation. Okay, here's our next equation. It's asking us to write it as a related function. So remember, we're going to change the 0 out to be a y. And then our a value is -1. Just to clarify, our b value is -4. And our c value is -4. You don't have to write it out the way I'm doing that, but that might help some people just to make sure they understand. And then go on to the axis of symmetry, which is -b over 2a. So it's going to be -4 over 2 times a, which is -1. Oops. And then -4 is really 4. You probably already knew that. Over -2, which is -2. The axis of symmetry, we use that so that we can get our vertex. So that's our x value of the vertex, because it was x equals -2. So we're going to plug in -2 into that equation. Everywhere you see an x, put parentheses. You have to follow PEMDAS or use your calculator so that you don't get that incorrect. So when we calculate this, we get 0, and so it's -2, 0 is our vertex, and then the y-intercept is always our c value, and the c value is -4. And again, we can start graphing and then pick our other 2 points, or we can just pick something near the axis of symmetry, which was -2, so we could pick like -1 or 0, but you might want to just make sure we haven't used it already. Okay, so once again, you want to pick points near your axis of symmetry. So for instance, -1 was right next to the axis of symmetry, which was -2. So I plugged in -1 in blue into the original equation, and I got -1, -1. And then I reflected that point over the axis of symmetry. You want to make sure you're graphing your axis of symmetry so that you can reflect over that axis of symmetry. Once I connect the dots and make my parabola, I'm looking for the zeros, the x-intercepts. In this case, there was only one, which is okay. It's at -2. So my x-intercepts is at -2. That's showing me when I find the zeros that I've solved the original equation that was equal to 0. It told us that we had to solve. So this equation is not in standard form to begin with. It's not even equal to 0. I need that 4x out of the way. Technically, I could just subtract 4x, or I can be lazy and just know it's going to become -4x when it goes to the other side. But I do want to put it in standard form. So x squared comes first, and then the x, so the -4x, and then the number, +5, equals 0. So when I write the related function, remember we're switching out the 0 for y. So it's y equals x squared minus 4x plus 5. And now, in case you want to see it, a is 1, b is -4, c is 5. And then we start with our axis of symmetry. X equals -b over 2a, which is a -4, over 2 times a, which is 1. -4 is 4 over 2, which is 2. So the x is 2, which means that my 2 is my x value of my vertex. I'm going to plug that back into the related function, the one that we put in standard form. So the y equals x squared, so 2 squared, minus 4x, so 4 times 2, plus 5. We calculate this either in your calculator or with your brain, and you get y is 1. So 2, 1. So I picked for my other 2 points, I chose 1, and I plugged in 1 into the original equation. You can see my work in green on the right, and I got 2. So 1, 2. And then I reflected that on the other side, which was 3, 2, when it was reflected. So now I have my other 2 points. I connected my dots to make my parabola. And then to find the zeros, the solutions, basically, of this graph, in step 3, I was looking for the x-intercepts. So if they have no x-intercepts, we're not crossing the x-axis anywhere, then there are no solutions. You can write it as none, no solutions, or the little no solution symbol.